Chapter 3 Test. Question 1. The quadratic equation k minus 1 x squared plus 2x plus 2k minus 3 equals 0, where k belongs to all real numbers, has two real distinct roots. Find the possible range of values for k. In this question we use the discriminant, which is equal to b squared minus 4ac, and because it has two distinct roots, we want that to be greater than 0. So a is equal to k minus 1, b is equal to 2, and c is equal to 2k minus 3. Substitute in. So we get 4, which is b squared, minus 4 times k minus 1, 2k minus 3, which has got to be greater than 0. If we multiply this out, we get 4 minus 4 lots. Multiply the brackets out, you get 2k squared minus 5k plus 3. It's got to be greater than 0. So you get 4 minus 8k squared plus 20k minus 12, which you get minus 8k squared plus 20k minus 8. Has got to be greater than 0. Solve the quadratic, you get k is equal to a half, or k equals 2. Therefore, draw yourself a little diagram. It's an upside down quadratic. So you get a half, 2. So you want everything to be greater than 0. So you want this part of the graph. So k is between a half and 2. So the values are k is between 2 and a half. Question 2. Let f of x equal mx squared minus 2mx, where x belongs to any real number and m belongs to any real number. The line y equals mx minus 9 meets the graph of f at exactly 1 point. Show that m equals 4. Well, if the two graphs meet, you know that mx squared minus 2mx equals mx minus 9. Therefore, you get mx squared minus 2mx minus mx plus 9 equals 0. Therefore, mx squared minus 3mx plus 9 equals 0. You are told there is exactly 1 point of intersection. Therefore, we want b squared minus 4ac to equal 0. Well, a is equal to m, b is equal to minus 3m, and c is equal to 9. Put those in, we get minus 3m squared minus 4 times m times 9 has got to equal 0. Therefore, 9m squared minus 36m is equal to 0. Factorize, therefore you get 9m. M minus 4 is equal to 0. Therefore, m equals 0 or m equals 4. Therefore, proven m equals 4. The function f can be expressed in the form f of x equals 4 brackets x minus p x minus q, where p and q are any real numbers. 2b. Find the value of p and q. Well, we know that f of x is equal to mx squared minus 2mx. We also know that m is equal to 4, so therefore f of x is equal to 4x squared minus 8x. If we factorize that, we get 4x, x minus 2, which is equal to 4, x minus 0, x minus 2. Therefore, p is equal to 0 and q is equal to 2. The function f can also be expressed in the form f of x equals 4 brackets x minus h all squared plus k, where h and k belong to R. This form is the vertex form. 2c, find the values of h and k. Start with f of x equals 4x squared minus 8x, which is equal to 4 x squared minus 2x. Now we're going to put the bracket in the vertex form, so therefore we get 4 x minus 1 all squared minus 1 squared. Multiply it out, so we get 4 x minus 1 all squared minus 4. Therefore, h is equal to 1 and k is equal to minus 4. Let g of x equal x squared minus bx plus 11. The point minus 1, 8 lies on the graph of g. 3a. Find the value of b. To solve this, we put in the point minus 1, 8 into g of x. Therefore, 8, which is your y value, is equal to minus 1 squared plus b lots of minus 1 plus 11. Therefore, we get 8 is equal to 1 minus b plus 11. Now solve for b. Therefore, b is equal to 4. 3b. The graph of f of x equals x squared is transformed to obtain the graph of g. Describe this transformation. Whenever you get transformation graphs, it's always better to put a graph in the vertex form. So let's start by putting g of x into the vertex form. So we get x squared plus 4x plus 11. If we put that into the vertex form, we will get x plus 2 all squared plus 11 minus 2 squared. So you get x plus 2 all squared plus 7. That means x squared has been moved 2 squares left and 7 squares up. Don't use the word move, sorry, use translated. Line L intersects the x-axis at point A and the y-axis at point B as shown in the diagram. The length of the line segment OB is 3 times the length of the line segment OA, where O is the origin. Point 26 lies on L. From the length of the line segments, we can work out that m is equal to minus 3. Therefore, we can use y minus y1 equals mx minus x1 at the point 2, 6. So therefore, we got y minus 6 equals minus 3, x minus 2. So therefore, we got y minus 6 is equal to minus 3x plus 6. Therefore, we got y is equal to minus 3x plus 12. 4b, find the x-coordinates of point A. At A, we know the y-coordinate is 0. Therefore, we know that 0 is equal to minus 3x plus 12. So 3x is equal to 12. So x is equal to 4. Consider the function f. The derivative f dash x is equal to 2x squared plus 5kx plus 3k squared plus 2, where x and k are real numbers. Show that the discriminant of f dash x is k squared minus 16. We know that a is equal to 2, b is equal to 5k, and c is equal to 3k squared plus 2. Therefore, using the discriminant b squared minus 4ac, substitute in the values, we get 5k squared minus 4 times 2 times 3k squared plus 2, which is equal to 25k squared minus 24k squared minus 16, which equals k squared minus 16, proved. Consider the lines L1 and L2 with respective equations. L1, y is equal to minus 2/3 of x plus 9, and L2 is y equals 2/5 of x minus 19 over 5. Find the points of intersection of L1 and L2. Using your GDC, draw both graphs and find the point of intersection. If you do this, you will find the point of intersection is 12, 1. The third line, L3, has the gradient minus 3/4. 6b, write down an equation for L3 if it passes through the intersection of L1, L2. Well, we know the gradient is minus 3 over 4, and we know that the intersection point is 12, 1. Therefore, we can use y minus y1 equals m, x minus x1, giving us y minus 1 equals minus 3 over 4, x minus 12. So you get y minus 1 equals minus 3/4 x plus 9. Therefore, y equals minus 3/4 x plus 10. 6c, L4 passes through the intersection of L1 and L2 and is a normal to L3. Write down the equation for L4. Well, if L3 has the gradient minus 3 over 4, a normal will have the gradient where m is equal to 4 over 3, and it passes through the point 12, 1. So therefore, we get y minus 1 equals 4 over 3, x minus 12. So therefore, we get y minus 1 is equal to 4 over 3x minus 16. Therefore, we get y is equal to 4 over 3x minus 15.